All right, this is 4.2 day 2. I got 15 minutes on the clock. Let's see what we can learn. Similar polygons. Okay, we talked about congruent polygons, and there were those set of rules to be congruent. We had all 6 pieces were congruent, and then we showed different smaller steps to prove congruence. We had our 5 different rules, but for similarity, the rules are different. If 2 polygons are similar, then their angles are congruent, and their sides are proportional. We talked about this a little bit yesterday, but you have to understand that similarity and congruence are different. When we talk about a statement of proportionality, we're talking about the sides of a polygon, and we're doing corresponding sides. So all of the top are from one polygon, and all of the bottom are from another polygon. And we're looking at ABCD and EFGH. And since they're similar, this little symbol right here says similar, we can then create these proportional statements where AB and EF are proportional because they're in corresponding locations on the picture. Let's look at a picture of this idea. So here's this ABCD. See how A and B correspond to the same location, E and F? That's where the corresponding statement comes from, or the proportionality statement comes from. Now we can also say not just the side lengths, but the angles. Each angle is congruent. So their angles are congruent and their sides are proportional. This gives us a lot of math to be able to work on. We can go both ways. If I tell you that they're similar, you know the angles are congruent. But if I tell you the angles are congruent, then you can tell me that they're similar. So if I look here, the 2 polygons are similar. You can write a statement of proportionality based on the length of each side. So I have here that they're similar. I'm telling you right here, A, B, C, D, and E, F, G, H are similar. So that means I can take that similarity and turn it into proportional statements like this. And I can also say angles are congruent. So angle A is congruent to angle E. B is congruent to F, C is congruent to G, and D is congruent to H. Notice how they went in order. A, E, B, F, C, G, D, H. That'll happen every time because that's the way we write the polygons, and that's the way we have to construct it. Just like the triangles, they have to go in a certain order. Same with the polygons. So here we're going to talk about the scale factor. Okay? This square is obviously not the same size as the blue square. It's been increased. It's been enlarged, if you will. And the scale factor, or the factor by which it was enlarged, is 3/2. To get from the red to the blue, we had to times it by 3/2. Now, to get from the blue back down to the red, we had to times it by 2/3. The proportion, or the ratio between these two polygons, that ratio we set up, that 2/3 or that 3/2, that is our scale factor. It's just the ratio between the 2 side lengths. Let's look at this crazy polygon. We've got the bottom and the top. We talked about this before, this exact polygon before. We're going to brush up on it again. We write our proportional statement. 8 and 4 correspond to each other, so we put 4/8. 5 and x corresponds, so we put 5/x. And now that's our proportionality statement. We do the cross product property. We divide both sides by 4, and we reduce our fraction. We get x equals 10. Now we talked about similar polygons have proportional sides, but they have equal angles. So 1/16 is the angle here, and it's equal to y minus 23, which is the angle here. So we set them equal to each other because they're corresponding angles of similar polygons are congruent. And then we add both sides, and we get our answer. Sorry, I went a little quick on that one. You add the addition property of equality allows us to say that they're equal to each other. This is another one we went over in class. So we have LJ, JN, MK, KP. That was given to us. We're not really sure if they're proportional, or if it's similar polygons or not, but we do know that those side lengths are proportional because they told us that. Now it's asking me to find JN. Well, I don't know exactly a lot about JN, but I know the whole thing's 16. And I know that JL is JN minus 16, right? If the whole length is 16, but then I take away this JN. Notice how I said take away? Take away means minus. So I take 16, take away JN, and I write it just as 16 minus JN. And that's how big JL is. So with that, I can substitute that into my equation. And then I can reduce my fraction, because 12/9 is big numbers, and I don't like big numbers. So I reduce my fraction, and I do the cross product property. I distribute in my values, and then I subtract my variables over on the same side, or I add them over, sorry, addition property. And then once I'm there, I divide both sides by 7, and I get Jn equals 48/7. I cannot reduce that fraction any further, so I leave it as 48/7. So these are the reasons for why I'm able to make the steps I'm making. Hopefully you guys understood the whole JL portion of the example. Now, what if I have this type of situation? I have x over a and b over x. Well, if I did the cross product, I'm going to pull out my pen here, see if I can do this right. If I do the cross product, I don't want to do black. Black's ugly. Let's do blue. If I do the cross product, I'm going to end up with x times x equals a times b. Well, now x times x, I know this can become, I can rewrite this as x squared, and that is equal to a times b. That b looks funny. Oh, goodness. All right, the b looks funny, and it bothers me. I'm going to fix it. Oh, geez. Just got rid of everything. X squared equals a times b. Again, looks weird, but who cares? To get the x by itself, I'm going to have to square root both sides. And I end up with x equals the square root of ab. Now, this scenario is special, and we give it its own name. We call it the geometric mean. So if I have two numbers, a and b, I know they're letters, but they're variables representing numbers, and they have the same proportion to x, so a to x and x to b, then I can say that the geometric mean between a and b is the square root of them. Okay, so the geometric mean between a and b is the square root of a and b, which is just x. Okay, so let's see an example of what this looks like. On your little cheat sheets for the test, you'll see that you have the geometric mean formula right there. So on the test, if I ask you what's the geometric mean between two numbers, there's no excuse. You have it right there. Square root of AB. So in this example, I'm looking for the geometric mean between 3 and 7. This means that I have 3 over x is equal to, x, x over that is equal to x over 27. This scenario provides me with the way to find out the geometric mean. But if you don't want to follow through with this example here, you can just plug in the formula. So I put 3 and 27 there. So I'm doing the square root. I'm going to call that, plug in the values in the formula, right? Find the formula you need, plug it in. So now once I've done that, I can break 27 apart into 3 times 2, 3 times 3. Okay? So I'm factoring the 27. And then notice how I have two groups of 3. Well, the square root of 3 times 3 is 3, and the square root of 3 times 3 is 3. So I'm pulling those out individually. I'm pulling out my pairs, or bring perfect squares out, and then I multiply 3 and 3 to get 9. Okay. Now, another way we could have done this. I got the square root of 3 times 27. 3 times 27, well, I know that's 81. And I know that the square root of 81 equals 9. So however you want to work it is fine by me. Just make sure you're able to plug in the numbers, multiply them, and solve. Now, we talked about scale factor earlier, but when we have two polygons that are similar, we need to be able to go both ways. I need to know that scale factor here is 3/2. And I need to know that the scale factor this direction is 2/3. Okay? You'll need to know that on the test. It's going to help you out a lot. And I'm going to show you why that's important right now. So right here, I've got two different shapes. And I'm asking you to set up the proportionality statements. Personally, when I set these up, I like to go with all of the bottoms and then do all of the tops. So I find my bottom number, or whatever one I want to start with. Here's my bottoms, 25. I go around the triangle, 25, y, x, 15. I go over to my top and I find what corresponds to 25. Well, it's the W. And I go in the same order. W, 16, 10, 12. Now, if you want to find each one individually and do 25W, Y, 10, 16, sorry, and then do X and 10 and 15 and 12, that's fine. You could also start on this side. You could say W to 25, 16 to Y, 10 to X, 12 to 15. It wouldn't matter as long as you set up the proportional statements correctly. Now, if we find the scale factor in this problem, we'll see that we say I need to set up one over the other. And I don't have any numbers except for here at the very end. I've got 12 over 15. If I have that, I can say that my scale factor, I just reduced that fraction down, and my scale factor is 4/5. So now this 4/5 is going from the top to the bottom. Okay. Notice how we're going from PQRS to JKLM, and it's 4/5. Now, if I want to go backwards, I have to do the reciprocal, and it gets me 5/4. Okay. Going one way is 4/5, going the other way is 5/4. All right. So this is kind of what we covered right now. If two polygons are similar, then the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Oh, this is new. Yikes. It's the same thing. Each one of these pieces has the same proportions. Okay? We talked about this. This was 12/15. We reduced it to 4/5. Each piece of the puzzle has the same ratio. That same ratio also applies to the entire perimeter and the entire perimeter. It's the same fraction. Let's talk about that. So if I have the proportionality statements, we've already got that done. I'm going to find W. When I find W, I'm going to set up my cross product. I'm going to divide 5 over. I'm going to reduce my fraction and multiply. Well, or you could just realize 25 times 4 is 100. 100 divided by 5 is 20. Either way works, but you could reduce this down and make it easier if you wanted to. So we're going to say 20. I plug that in for 20. Now I find X. Set up my cross product, divide by 4, reduce down my fraction, and I'm left with 25 halves. Notice how I take the 5 and times the 5 gives me 25. The 2 on the bottom is a 2. Okay. Now it says find Y. I identify my pieces. I do my cross multiply. I divide by 4. I realize the 4 becomes a 4 on top, which gives me a 20. So Y equals 20. I'm going to plug all those values in, and I'm going to find my perimeter. W plus all of those pieces gives me W plus 38. Well, W is just 20, so the perimeter of the first one is 58. Now, if I knew my scale factor, I could take this number, multiply it by that scale factor, and come up with the perimeter of the other polygon. Okay, let me show you that later. But right now, just remember 58 timesing by the scale factor gives me the perimeter of the other shape. So let's find that perimeter by itself. Oh. If I do that, I come here and I say, well, the perimeter of the other side is X plus Y plus 25 plus 15, which gives me 25 halves plus 20 plus 25 plus 15. Ugh, fractions. I need to add all of my fractions with the same size pieces of pizza. So I multiply each piece by 2 over 2. I'm just timesing each one by 1, because 2 over 2 is 1, which is a fair move to do. I can times anything by 1 because it's just itself. But I'm doing it in a way that's going to create a fraction on the bottom that is the same as the other fraction. So when I do this, I end up with 40 halves, 50 halves, and 30 halves. Now I can add all of my fractions across the top and end up with 145 halves. So I just found the perimeter of the other side. So now I can say that 145 halves and the ratio of 145 halves to 58 is the same as 12 to 15 or 4 to 5 or however you want to look at it. So if I take 58 and I times it by my proportional statement, 20 seconds left, sorry I ran out of time. I multiply it by 5/4 because I'm going from the smaller one to the bigger one. I get 290 fourths. I reduce that down and I get 145 halves. So yes, you can multiply it by the proportion statement or the ratio and you'll be fine, the scale factor. Summarize what you learned, do your homework, enjoy the notes, and hopefully this will help you review for the test.